Hello, Zumanga. Zumana. Good morning.
Yeah, good morning, ma'am.
Yes, can you hear me? Zumana?
Yes, ma'am. Yes, I can
Yeah.
hear you.
Yes. So we just wait for 2 3 minutes and we start after 2 minutes.
Okay, no problem.
Okay. We just
Okay, no
wait.
problem.
Okay. I just share my file till then. Right? Open my file. Yes, good morning, Abdullahi. So why you left, Abdullahi? Was there any technical issue? Okay, okay, fine, fine. So what? See, this is your theory class, right? Next will be your lab. Okay. So, and I think Norbert, please, you were there yesterday in the lab session when your network was no disconnected again and again.
Yeah.
Okay. Okay, right. So this is your theory session. So what we were doing yesterday in this theory session, anybody remember where we left? We were doing. Yes, yes. Please go ahead, Norbert, please.
Well, talking about input devices,
Talking about.
input, input and output devices.
Very good, right. Input and output devices, yes. And after that, we completed input and output devices. Okay. And Abdullah, you also want to say something? Yes, yes, Abdullah, please go ahead. You raised hands. Okay. So, uh, you were there yesterday in this theory session. Zomana and Abdullah, you both were there yesterday in this theory session. Yes, please tell me at least yes or no. You were there or not, Abdullah and Zomana? I'm asking both of you. So you should remember what topic we completed, what we started. So we completed input and output devices. Okay, Abdullah. And then what topic we started with, I'm asking. You remember what topic we started? I left in between. Yes, Norbert, please, please.
Yeah, we are talking about storage devices,
Very good.
their
Right.
purpose.
Very good. Yes. We completed input and output units, input and output devices, and then we started devices. Okay, storage unit. Very good. So I told you different types of memory: primary memory, secondary memory, internal memory, and today I said we'll discuss these memories in detail. Okay. So I just Open my file. Zumana and Abdullahi, I want you should also please be more responsive and more attentive. Okay. Okay. So this is we started yesterday memory representation, right? And then in fact, I told you to tell me what units we have after GB and TB. Anybody studied about that? I told you to study what memory unit we have after TB. It is not limited up to TB only. We can measure memory capacity more than in TB also. What is that? I told all of you to study and go through this. Yes, anybody found out what is a bigger unit than TB? Okay, yes, right, right. Okay, so I want Abdullah and Zumana, you also go through this and let me know if you can find out. Okay, right. So, okay, then after this, yeah, I told you three types of memory: internal, primary, and secondary memory. Okay, and this diagram I discussed, I explained. Okay, so what is the basic differences? Three basic differences between these memory. So, can anybody brief what is what was explained in this diagram? Yes, Zomana, Zanga. I explained this diagram yesterday. Can you repeat this? At least say yes or no, Zomana. You should reply at least. Open your cameras. Why don't you open your cameras? Zomana and Norbert, please, both of you. Open your videos. Yes. And Zomana Zanga, can you open your camera? Yes.
Yes,
So
ma'am.
do you remember what I explained in this diagram yesterday? And if you don't remember, at least say no.
No, ma'am,
I
I don't have any idea.
okay. At least it tells me whether you are listening or not. Okay. At least reply yes or no. Anyways, yes, Norbert, please can you explain this diagram to Zomana?
Yeah, I can try.
Yes. Please go ahead.
Well, I will start with the capacity, the storage capacity, where we have the, the internal processor memories, which is registers, cache memory. Mm, what they have, like, their storage is low, though their cost is high. This is due to their accuracy and speed, their performance. Then we have the RAM, RAM and the primary memory. Their costs are also a little bit higher than the hard disks due to their faster speed and accuracy, and also it's easier to access. Their access speed is a little bit faster. Then the hard disk and the magnetic disk are slow, so their storage is high. They have a high storage capacity at slow access speed. That's all I can remember.
Yes. Did you get it, Zomana?
Yes, ma'am. I try to understand it a bit.
Sure.
Yes.
So now you can repeat what he said.
Okay, I will come later because I will try to write down, and then after that I will try to.
Okay. So I just proceed and then you interrupt me when you are ready to explain. Okay.
Okay.
Right.
Okay.
Okay. So this is the chart. I explained that we have three types of memory: internal, primary, and secondary. Then now I'm explaining these in detail, right? So I explained the basic features here. Now I'll explain the devices that come under primary memory, that come under secondary memory. Like in primary memory, RAM and ROM; in internal memory, registers and cache memory. These two types of memory come under processor memory. Why they are called processor memory? Because yes, anyone? Why they are called processor memory? Because
because in the central processing,
they are, yes, they
process
are placed on the CPU. Okay, and that is why CPU takes least time to access that, okay, data stored in this memory, and that is why they are most expensive. Okay, but yes, they have very minimum storage capacity. Then RAM and ROM comes under primary memory. Okay, and hard disk and magnetic disk, pen drive, all these CDs, everything that come under secondary memory. They have a very large capacity, like we have hard disk in TVs now, but they they take the maximum time. CPU takes the maximum time to access these memory. Okay, that is why they are cheapest. Okay, they are slowest. Okay, and but yes, RAM and ROM come between before hard disk, so CPU takes less time than hard disk. So what we do, we pick up the data from hard disk and place it in RAM so that it can be picked up by the processor faster. Okay, so that is why they are expensive than hard disk, because they are faster than hard disk, right? So this was the summary. Now we'll study these in detail. So first, I'm telling you about RAM. As I was saying, that what we do, we keep the data ready in RAM. Okay, we bring the data from the hard disk and keep it in RAM, so that CPU does not need to go to the hard disk. It will just pick up the data from RAM. But the problem is that one is that its storage is less than hard disk. Okay, second is that it is volatile memory. Volatile memory means this is not permanent memory. Okay, here whatever data you are storing, that stays there till the power is on. Okay, so if suppose you are writing something on the MS Word and you have not clicked save button, so it will show you that document. Okay, but if power goes off in between, so that data will be lost. If you have not clicked save button, if you click save button, that means that data will get go and get saved in hard disk. Okay, RAM is what is opened, no, the screen that is opened on your system. So you can take that whatever screen is open, that screen takes memory in RAM. Okay, whatever work you are doing right now, that takes memory in RAM. So the more the RAM, the more data you can open on your screen, but that is not permanently saved. So RAM, this is the advantage and disadvantage of RAM. Faster than hard disk, but disadvantage is expensive than hard disk, then storage is less than hard disk, then main is this is not permanent storage. Okay, it will store only till the power is on. Okay, and if it power goes away or you switch, your system gets switched off, so the data will be lost. Okay, So now we have types of RAM. There are two types of RAM, SRAM and DRAM. That is static RAM and dynamic RAM. Okay, what is the difference between them? The RAM we use in our system, that is dynamic RAM. Okay, that is dynamic RAM and that is cheaper. Static RAM is expensive. Okay, so what is the difference now? So in static RAM, the memory retains its contents as long as power remains applied. Okay, you don't need to refresh it periodically. But in DRAM, you have to refresh, you have to keep refreshing the memory. You have to continuously refresh it in order to maintain the data in DRAM. Okay, so but this is cheap, so that is why most of the system have DRAM, right? Then next come to the ROM, because what we are studying here, first I'm telling you these two types of primary memory, RAM and ROM. Okay, right? Romana, clear what we are doing? So in ROM, what is the full form of RAM? I didn't tell you the full form of RAM. Anybody knows the full form of RAM?
Random
Random access
access
memory.
memory.
And full form of ROM? Read only memory. Okay, now why this is called read only memory? Because this memory user cannot write any data in it, we can only read it. Okay, and who can write it? This is generally comes, no, the manufacturers of computer, they write instructions on the ROM and that gets fixed, that no, it comes fixed in your system, pre-written, predefined, which is written by the manufacturers. Okay, it's not only fixed in computer, in whatever other electric devices you purchase from the market, whether it's your microwave or whether it's your no fully automatic washing machine, oven, these kind of gadgets also. So in all these kind of fully automatic gadgets also, they have ROM inside them, where the instructions are written that what operation these machines will perform. Okay, so we cannot change them, right? We can only use them. Press this button or press this button for this operation, press this button for this operation. So we cannot change them. Okay, they comes pre-written by the manufacturers of that device. Okay, so this is read only because we can only read them. Second, this is permanent. It's not like when power goes away it will be lost. No, this is non-volatile. Volatile means RAM. RAM is volatile memory. Volatile means temporary memory. Okay, but ROM is non-volatile. This is permanent. Once this is written by the manufacturer, now we cannot. It will be there permanently. Okay, it will not be lost when power goes away. Okay, as I have given example of washing machine, oven, etc. Okay, so these are kind of chips, you can understand, right, where circuits are designed for whichever operation these machines are manufactured. So for those operations, the chips, the circuits are designed on those chips. Now we'll study about the types of ROM. Okay, now we have two types of RAM, but we have four types of ROM. What are these four types of ROM? First is masked ROM. Masked ROM is that we are studying a normal ROM. Okay, where a program, or you can say the set of instruction that is already written, and we can only read them. Okay, and written means, as I just explained, these circuits are already designed on the chips. ROM are basically chips. Okay, memory, that is basically chip. So this is ROM, which is already instructions are manufactured. Then second type of ROM is what is programmable ROM, PROM. Okay, now what is programmable ROM? Programmable is, okay, we give the flexibility to the user that they can make the changes once. Only once you can rewrite the instruction. After you have make after you have made changes in that ROM, After that, it will become Rome again. PROM will become Rome when you have written or you have changed the instructions once. Is it clear? Is it clear? Programmable ROM is that you can make the changes in the instruction. Okay, but once only. And after, no, one time you have made the changes, after that this will become Rome only. Why? Because like Rome, you cannot make the changes again. Is it clear, Zomana and Norbert, please, both of you? This point is clear?
Yes.
Okay,
Yes.
yes. So that means you can make the changes only once, right? That is programmable. You can program it only once. This is also all type of ROM, as I said, non-volatile means permanent. Okay, so the data will get be stored there even if the power is switched off. Even if the power is switched off, right? Next is EPROM. Erasable programmable read only memory. What is EPROM? Erasable. Now here it gives you the flexibility that user can erase it and rewrite it as many times as you want. Okay, like in programmable PROM, you can rewrite it only once. But here in erasable EPROM, you can make the changes as many times as you want. This is the difference between PROM and EPROM, right? But there is one more point in EPROM, that if you have to make the changes, you have to erase the entire ROM and then you can rewrite it. You cannot be selective. Okay, suppose there are no 100 lines of 100 lines are, suppose 40 50 instructions are written there and you want to make changes in 4 instructions. But in EPROM, you will have to erase the entire data and you have to rewrite the entire data. So there is no flexibility. There is no like you can go and change the selected area only. No, right? So here, this is obviously because more flexibility is given to the user, that you can rewrite it as many times you want. So that is why this is expensive than PROM. Okay, and how you, as I'm saying that you can erase it and rewrite it, so how it can be erased? It can be erased by simply exposing the device to strong ultraviolet rays for a certain amount of time. Then that data will be erased and then you can rewrite this chip. Now next is EEPROM, electrically erasable programmable. What it says, that yes, like in EPROM, you can erase it and rewrite it as many times as you want. Same way, in EEPROM also you can erase it and rewrite it, but here you can be selective. Selective means you don't need to erase the entire chip and rewrite the entire chip. You can just erase that particular portion of the ROM which you want to change, right? And how you can erase that particular data? By electrical charge. Okay, it can be raised by an electrical charge, and then again you can rewrite it giving it the normal voltage. Okay, so rather than erasing the entire chip, what we were doing in this third point, EPROM, here you can erase one byte at a time. Okay, so obviously this is more flexible than EPROM. Am I clear? Yes, you want to ask something, Norbert P?
Yes. What's an electrical charge?
What?
What's an electrical charge?
Electricity, you when you pass the current. Okay, okay, then what is next? So this we did the 4 types of ROM, right? Masked ROM, that means normal ROM, then programmable, that you can rewrite but only once. Next is EPROM. You can rewrite as many times, but the entire chip has to be rewritten. And next is EEPROM, where you can be selective, okay, and which, what do you say, portion you want to erase, okay, right? And next is, so we did the types of RAM and types of ROM. Now, next is here, as I said, in this diagram, I explained that RAM is also, it will take time for the processor to come and pick up the data from, I mean, not come, but from RAM, it will take time to fetch data from RAM. Okay, so the data, when the data arrives from the RAM to the CPU, so it takes some time. So we want it to be more faster. We want to make it for more faster, this accessing of data. Okay, because we don't want to waste CPU time, because that is the most expensive part of a computer. Okay, so we want the CPU to sit and wait for the data to come. So what we do, we add one more layer between RAM and CPU, so that it should be more near to the CPU, so that it takes less time to pick up. So that is the cache memory. Okay, that is the cache memory. That is the layer between RAM and CPU. Okay, so it will take less time than the RAM. Okay, so this is a small and fast memory between CPU and main memory. Main memory is your RAM. So this is faster than your main memory, right? Main memory, we call RAM as the main memory. Then comes the register, which I said internal memory, which is placed on CPU itself. Okay, so this I told you that registers are the fastest, but the thing is that they can only store up to 8 bits, 16 bits, or 32 bits. Earlier, in earlier times, computer used to be only 8-bit computers or 16-bit computers. Nowadays we have 32-bit or 64-bit. Okay, so these bits means 64-bit means it has 64 register, and each register can store only 1 bit of data. Okay, so it doesn't have so much memory, but yes, these are the expensive part and fastest memory, right? So we did the internal memory, two types of internal memory, and we did these two types of internal memory and two types of primary memory. Now I'll come to this secondary memory part. Okay, so where we have all these CDs, floppy disk, hard disk, magnetic disk, all the devices come under secondary. So first of all, we can divide all these devices in two categories: sequential access devices and direct access devices. What do you mean by sequential access and direct access? Sequential means where obviously in the device, when you have so many records, okay, when you have so many records, and you have to access all the records sequentially, one by one only. Like if you have 100 record, you cannot directly go to the, if you have to read 80th record, you cannot directly go to that 80th record. You have to pass from record 1, 2, 3, 4, like that. You must have seen, I don't know whether you have seen it, or like nowadays we have these disk, hard disk. Earlier we used to have magnetic disk, that kind of audio cassettes and video cassettes. Have you seen that? There used to be some kind of, you call it elastic, or no, some kind of ribbon, you can say. Have you seen these kind of audio cassettes and video cassettes? So these were long back, so I don't know whether you have seen it or not. They used to be audio cassettes and video cassettes. They were like magnetic disk. They are the example of magnetic disk. So what was there, like you can, if you have to, there are suppose uh, 10, 20 songs in one audio cassettes. Okay, so if you have to listen to 15th song, so you cannot go to directly 15th song. First you have to pass from uh, So first you have to pass from record 1 to record 14th. Okay, but yes, okay, so you can just forward it, okay, fast forward it, but you have to go through that. You have to pass. You cannot directly go to the uh, what do you say, 15th record. Okay, so that is called sequential accessing. Sequential is one by one you can move or go to the record. And direct access devices, so those magnetic tapes what I was saying, those come under your sequential access devices. And what is your direct access device? Like we study about hard disk, your CDs, if you have seen in movies, where you see that you can directly place the recorder at some place and it will start playing that song for you. Okay, so that is called your direct access. So you can directly go to a particular record. You don't, if you have to listen to 90 record, you can directly go to that record. You don't have to pass through 1 to 89. Okay, so that is called your sequential access devices and direct access. So whatever all these storage devices you have, all these storage devices will come under sequential or direct. Okay, so now we'll study all these devices one by one, right? So first of all, magnetic tape. So what I was telling you, just a second. Yeah, so magnetic tape, what I was just telling you, that this is kind of audio cassettes and video cassettes, where you can see the tape here. Okay, so that is your example of magnetic tapes that comes under sequential access device. Okay, and nowadays we don't use them. Nowadays we use hard disk and all the other devices, CDs and all we have, right? But earlier it was in trend, right? So nowadays it can be used only for offline data storing. What is offline data storing? Online data storing is like I'm working on the system, and that time online my data is there in the hard disk, right? And offline is you can store your data in you can store your data in this magnetic tape, and then you can keep it somewhere. Okay, in some almira and all that, right? So obviously, but this is not used for online data. I mean, you cannot keep it in your laptop and keep working on it. Okay, so where you need to update or revise your data, or read your data again and again, for that you cannot use magnetic tape, because it can be accessed only sequentially. Okay, but yes, this was a cheap mode of offline data. What I just explained, what is offline data, it can store large amount of data. Okay, and it was cheap also, and lightweight, compact in size, right? But again, as I said, it can be used only when you have to access your data sequentially, where you feel okay, like I have to access my data one after another. There you can use magnetic tape. Okay, they have less wear and tear also, and but uh, you cannot use it for your online accessing of data, where you know that it's not going to be sequential, right? So it gets corrupted if you keep it in dusty environment. So these are the advantages and disadvantages of magnetic tape, right? And then next is your magnetic disc, which comes under which kind of devices? Magnetic disc comes under which category? Magnetic disc. Yes. Yes, I just shown you two types of category for all these storage devices. So magnetic tapes comes under which category, and magnetic disc comes under which category? I'm asking. Anyone? Francis, Zomana. Francis, Zomana, you both are not listening, or you're not getting it. Yes, they all are secondary storage, but I just said all the secondary storage devices can be categorized in two categories. What I was explaining for so long, sequential access and direct access. So I just said magnetic tapes comes under sequential access because here all the records can be accessed one after another. In direct access, we have first of all magnetic disk. I'll explain all these types of disk. First of all, I'm explaining magnetic disk. They all come under direct access, means directly you can access any record. You don't need to go to all the 9 record. If you want to listen to 10 song, you don't need to fast forward 9 records. You can directly go to 10th song. Is it clear? I hope so. So this is your magnetic disk. Yeah, that is your like kind of hard disk what we use. Okay, that is the example of your magnetic disk. Okay, now here I am explaining the technology how data gets stored in your hard disk. Okay, so we know that data gets stored in the form of 0 and 1, and these are called online secondary storage device because while working on the system my data gets stored. Okay, I can read and write data while I'm working on the system, so that is why they are called online secondary storage. Now the thing is how it will get stored. Okay, so how it will get stored? What we do basically, if you have heard that we what we do that we format our hard disk. Okay, so now what is the meaning of formatting the hard disk, right? So the meaning is that first of all we divide the disk into some circular shapes. Okay, and that is called your tracks, and then these circles are divided into some pie shaped uh, structure. Okay, so now can you see these are like circular shapes, so we divide the hard disk in some circles. Okay, and then these circles are divided in some pie shaped segments. These are called, what is this called? Tracks and sectors. So these circles are called tracks, and these circles are divided in pie shaped area that is called segments. Okay, now why we divide it? This is not the physical division. This is not like I'm drawing circles on my hard disk. This is just like logical division. Logically, we are dividing it into some tracks number, and all the tracks are divided into some segment numbers. Why we divide that? Because whenever we store the data which gets stored in the form of 0 and 1, whenever I will read it or I will search the data, that data will not be searched by its contents. Data will be searched by its address. Okay, so now what is that address? Address is the its track number and its segment number. So whenever you will save the data, it will get saved on some particular track or some particular segments on that track, and whenever you will read it, search it, it will go to that particular track number and the segment inside that track, and then it will read the data stored in on that address. Okay, so just to give it some address, like we have some home address which is divided on some plot number, right, flat number, building, like that. So the same way we divide our hard disk logically, not physically. Logically we divide it into some circles which are called tracks, and these circles are divided in some pie shaped, which is called segment. So which I just showed you here, these circles. We have many circles over there. Here I'm just showing one. Okay, and what is hard disk? Hard disk, you can say, the collection of, no, what we are seeing here, this is one platter. Okay, so we can say that this is a collection of many platter or many disk, you can say. Okay, so here like you can call them, there's not only one platter or one disk. Like CD we have one disk, right? So in hard disk we have this collection of disk, or we call these disk as platter. Okay, now first thing is, these circles have the track number and segment number. Now how these are stacked, how they are collected on one above the other, this is called the stack. Okay, now they all have one reader and writer. They all platters. Okay, data gets stored on top of that also, and on the bottom of that also. Okay, like here this is one plate. Okay, and on the top of this also you will store your data, and on the bottom side also, both side you will store the data, except the top of the first platter and the bottom of the last platter. These two sites we will not store any data, because there is a fear of some, no, hard disk can get crashed if it is, no, hit by something. So that is why we leave this blank, the top side of the first platter and the bottom side of the last platter, and rest other whatever number of disks are there between them, the data will get stored on both sides, up also and down also. So if I'm showing these three platters in my hard disk. So on how many layers I will store the data here, how many layers it has total, and on how many layers I will store my data. Yes. Yes, I'm asking something, please reply. What question I have asked? Anyone can repeat my question? Yes, Zumana, can you repeat my question, what I asked? Can anyone repeat what I asked, Zumana? I'm not asking for the answer, I'm asking the question I asked. Francis? Norbert Peace did not get what I asked. So can you explain him what I asked? Yes. If there are 3 platters like this I have shown in this diagram, then on how many layers I'll be able to store the data? According to the rule I just explained, on which layer we cannot store, then in total how many layers we can store data? No reply.
No idea.
I have changed the slide. You go through here and go through this and then tell me. See, I said you can store data on both sides of the platters. So, for if there are 3 platters, then how many total layers are there? Norbert, please.
6.
6. You have written 8. Okay. 6 layers are there. But I said on the top layer of the first platter and on the bottom layer of the last platter, data is not stored. Then how many layers are left for storing the data?
4.
4. Yes. Total are 6 layers, but on the top of the first layer and on the bottom side of the last layer, you don't store the data because it has the chances that the hard disk will get crash or it hit by something. Then the data on this first layer and on the last layer can get crashed. Okay, now what I'm telling you, for each layer you have different read and write arm. What I was saying, that you must have seen in old movies, that there used to be some CD player, and no, you can keep that read and write arm on that to play that song. So for each layer you have a separate this read and write head, okay, which will read or write data from this layer. Then this is for the bottom layer, then for this top layer, then bottom of this second platter, then top of the third platter, bottom. For each layer you have a different read and write arm. This is called read and write head. Okay, right? Yes.
Yes.
Right. So you have this read and write head, and then what, all these read and write heads are fixed in this arm assembly. This is called arm, and this is point which no reads and writes on this arm. This is called read and write head. So this is read and write head, this is read and write arm, and all the arms are assembled or attached to this one, you can say read and write, this you can say arm assembly. Okay, so this all these and writes head are attached to this arm assembly. Okay, now how it will, suppose your data is here on this track and on this sector number right here. So you have to you have to rotate your platter so that this segment should come under this read and write head. Is it clear? You have, I mean, not me, this motor has to rotate this track. Okay, because all these tracks are numbered from 0, and it will keep on increasing 0, 1, 2, 3, like that, from the outermost to the innermost. They are numbered from the outermost to the innermost, starting from 0, right? And these are tracks, circular division, and this on this track, this is called the sector. Now if you have to read from this sector, you have to rotate this motor. This is kind of spindle in between which will rotate these platters. So it will rotate, and it will bring this particular sector under this read and write arm. Okay, now then there is one more point, that all the disk will be rotated. It's not only one platter will be rotated, all the platters will be rotated. So basically all the platters will be on the same track and sector number under this read and write arm. For each platter, they will be reading the same track and sector number because they all are rotated simultaneously. So this is that all the tracks and sectors will be on the same positions. All the platters will be on the same track number and sector number. Okay, so this makes a cylinder. This makes a cylinder. I mean, this is not physically there is a cylinder. This is just a shape that all the read write arms will be reading the same track and sector numbers. Okay, so this is the structure of hard disk that we use, how there are many platters, how they are divided. When we call that we are formatting a hard disk, so basically we are dividing it into some logical tracks and sectors. There is a kind of spindle in between which rotates this platter so that this read write head can read the particular track and sector number. Whenever you say read this file, open this file, it will go to that track number and sector number. It will search that file with its track and sector number. Am I clear till this point? How this hard disk works? The technology? Yes? Should I move? So what are the advantages? Obviously, very cheap. You know, hard disk is very cheap nowadays. Their storage capacity is, you can say, like unlimited. So much is the size for those disks now, and you can easily move it from one place to another. This can be used as an online and offline, both storage device. Online means you can use it while you're working on the computer or your laptop. It is fixed inside that. Or if your hard disk is full, then you can keep it in, some almirah or some locker, and they can, that time it becomes offline data. When you feel okay, now this data is not used regularly on daily basis, then you just store that data and keep it somewhere safe. That becomes the offline storage. You are not using it on regular basis. Okay, so these are some advantages. And disadvantages is, again, it must be stored in some dust free environment. And if this can be direct access device, right? This is direct access device. So if your application is where you have to use all the, you have to access all the records sequentially in a sequence, then you can use magnetic tapes. Okay, you don't need to use magnetic disk. Okay, and this is more expensive than magnetic tapes. So these are the advantages and disadvantages. Then again, there are different types of magnetic disk. First is floppy disk. So earlier, I don't think you have seen this kind of floppy disk like CDs, if you have seen. So before that, we used to have floppy disk. It kind of square shape, very lightweight. Okay, very cheap also. Floppy disk for data storage. Okay, so like CD, we can move data from one place to another. So we used to transfer data from one system to another in floppy disk. Okay, so that was your floppy disk. Then your hard disk, which I just explained. Okay, then read write operation, I have told you how we read and write in hard disk, or you can say magnetic disk. So the technology is same for CDs also, for hard disk also. Okay, and as I said, that all the files get stored by its address. Okay, so where it stores that this file is stored, computer need to store this information also. Like it makes an index. Okay, this file is stored on this address, this file is stored on this address. Okay, so that is file allocation table, that operating system maintains this fat file allocation table, where it maintains that this file is stored at this address. Okay, so whenever you will search a file, it will go to that particular Address means sector number and track number and sector number. Am I clear till this point? Zumana, any doubt? Anyone? Any doubt in this? Norbert, please, you want to ask something?
Not really.
Okay. So this is the technology of hard disk, floppy disk. Then there is one zip disk also. Zip disk means which has its that storage device also. Then reader also. For CDs we have a CD player. Okay. In laptops also we used to have one CD reader also. So this zip disk is which is there is one disk also therein that comes with its reader, that comes with its cable, that comes with its power supply and software. So everything is in that one storage device. Okay, in that one storage device you can, it has a storage of very less storage obviously. So nowadays we really don't use this also, 100 to 250 MB. Okay, so it kind of, you can say, like we have CD player, right? So it has its own power, it has its own power supply, or its operating software. Okay, and like this on installation, when you install this gets a separate logical drive. You remember, if like in pen drive also, if you put a pen drive, it gets a different logical drive, E drive, F drive, something like that. Okay, so zip drive is the reader which has a disk also, its reader also, its software, its power supply, everything in one box. Okay, that is called as zip reader. Then yes, we have studied about all kinds of disk. Okay, secondary storage, primary storage. Now there are some ports also. What are the ports? Anyone can tell me what are ports? Have you heard about ports?
Yes.
Yes, tell me. Yes, tell me, Norbert, please, you want to say something? Yes, anybody? Nobody has heard about ports? You haven't heard about ports in a system? Yes, Francis?
Let me try.
Yes.
Ports. These they are receptacles for peripheral devices that are
Yes,
plugged
right.
into the computer.
Yes, where yes, Zumana, you are also correct. Actually, there are, one is your physical ports and one is your logical port. Okay, so that kind of port we'll discuss in networking, where what you are talking about virtual connection point. Here we are talking about the points, no, where you plug in your pen drive, where you connect your printer cable, right, mouse cable, keyboards cable. So that is called your slots on your motherboard. Okay, so where you plug in your external devices through cables. So those are the ports. So you must have seen these. Then again, these ports are divided in different categories. One is serial ports, which have this kind of 25 pin model. Okay, and this was the oldest type of connection points, you can say, which was used for modems. Now modems are not used nowadays. Then came parallel point, which was again this 25 pin. Okay, and this is parallel point. What is the serial? Serial means one bit will be transferred at a time. One bit, then after that second, then third. But parallel bit means, parallel ports means parallelly, that data, multiple bits will be transferred at a time. Okay, so that is kind of used with your printers when you connect your printers. Then USB, you know that your pen drive is also called USB, because this kind of connection or ports, we call them USB. Okay, where you can connect your cameras, your iPhones, your, no, USB points or ports, you can call them scanners, external hard drives. So all these devices you can plug and play. Plug and play means the time you connect it, you plug your, no, cable, and it will start reading it. Okay, so there is already cards are already installed for those devices. Okay, like for printers you have, we call it driver, right, to should be installed before that, right. So these are your ports which are used to supply electricity and for chargings. Mobiles can also be connected with computers, right. This is all about USB ports. Then if you have seen that on the right bottom of your laptops, or of your computer, you have a icon which says that safely remove hardware. So first, this is just showing that how it is just showing that how you can plug out, or you should remove your USB. Okay, so you should go to that first, safely remove hardware, close it, and then remove your pen drive. Then yes, we did serial port, parallel port, USB port, and fourth one is your SCSI port, which are used to connect printer, and it can connect up to 7 devices, hard disk, scanners to the same port. Okay, and their transmission rate is speed is also higher than serial and parallel ports. Okay, so they can read at a more speed than other ports. Am I clear till this point? Any doubts? Should I close this file? And your port.
Yes.
Okay, just a second. So, are you guys ready with your system for today's lab class? Francis, are you able to install that? You were saying there is some challenge. Norbert P. Zomana, I'm asking everyone. I mean, in today's lab session, you will be able to do it on your system. Your system is ready where you can work in MS Word along with me. Yes, I'm asking all of you. Okay. So Zomana's system is ready. You're talking about yes is about system, or about what the file we closed? About the lab or about the theory, Zomana? This yes is for the theory or for the lab? Francis and Zomana. Okay, you are not ready. Okay, Zomana is ready. And Francis, you are also ready with your system for the lab? Yes, Francis? Oh, very good. So be fully ready, not almost. Okay, so we'll continue in lab. Okay, now I'll continue this theory session. Yes, Norbert, please, you want to say something?
No.
Okay, now I just open the next file. Just give me a second. So we in the first lecture we did the computer fundamentals. Okay, different components of computers and the generations of computers, right? And in second lecture we did the input and output unit. We started in today's third lecture. We studied about the storage unit. Okay, now we have almost studied about all the hardware part. Okay, now we'll study about the software part also, right? So what is the, because in the first lecture I said that computer is the collection of hardware and software both. Okay, so now we'll study about the software. Okay, so just a second, let me share my file. What is software? Francis, yeah, just a second. Francis, you are asking about the lab, I mean, IGNO material. Francis, you are asking about the IGNO. Just a second, Norbert, please. I come back to you. Yes, Francis, you're asking about IGNO material. Okay, so you can find it. I think there is E-Gyan Kosh, and on this LMS, you don't have the study material. On LMS, the study material is not available. Anyone? LMS, on LMS, you have the study material. Otherwise, you will find it on the internet. E-Gyan Kosh, IGNO study material. If you will write CIT study material, you will find it on the internet, Google. Okay. Yes, Norbert, please. You were saying something. Francis, on IGNO, if you type IGNO study material, CIT material, you are doing this course is CIT. So you will find this. There is one website E-Gyan Kosh. EGYAN Gyan Kosh, KOSH .ac.in. You will find it on that site, or on your LMS also you can search. Okay. Yes, Norbert, please. You were asking something.
I was giving an answer on software.
Nothing. Okay.
Yeah, there's no question.
Okay. Just a second. Just give me 2 minutes break. Okay. Just have water. Just give me 2 minutes. So yes, I was asking what is software. As I said, we have started about the hardware. Okay, types of printers, types of scanner, different types of input output devices, ports also we have done. Now we have to study about software. I'm asking what is software. Yes. Yeah, very good. Yes, Francis.
Yeah, so a software is a set of instructions or command that tells the computer what to do.
Yes, right. Okay. So yes. Somebody else want to say something? Any other input? No. Okay. So as we did in the first class, we give instructions to the user. Or sorry, we as a user give instruction to the computer, right? And those instruction, those programs, whatever programs we will. I mean, you haven't done that, but later in further semesters, you will study about programming. So we learn how to write a program, and program means set of instructions. Okay, where we write many instructions, so that makes one program. In one program, we can write many instructions that we want computer to perform for us. Okay, and the collection of programs makes your software. Am I clear? Collection of instruction makes one program, and collection of programs make one software. Right. So that is now what is the difference between hardware and software? That also we discussed. So as I have said earlier also, like this classes should not be like I am no keep on speaking and I don't know how much you are getting, how much you are listening. So I want responses from your side also. So I should be aware that yes, these students are listening to me or understanding or getting what I'm speaking or teaching. Okay. You should be very attentive and responsive. Yes, so okay, Zomana and Francis. Difference between hardware and software. No idea. Okay. Yes, Francis, tell
Yes,
me.
Francis, tell me.
Hardware is a physical part that makes up a computer,
Hmm, very good.
Very good.
What is
What?
whereas software is a program that runs a computer.
yes, right.
Yes, right.
Beautiful.
Beautiful.
So we can say that hardware are those parts. Okay, Norbert, please, you also wanted to say something. Please go ahead.
I was responding to what you said earlier.
Yes. So hardware is basically the physical parts, as Francis said, the physical components of a computer, which you can touch, which you can see, okay, and which you can feel. And software, you can say those set of instructions, okay, according to which computer works, and you cannot see them, you cannot touch them. Okay, that is those instructions, right? So this we have to start now. That hardware part we have started. Now we'll start studying about the software part. So I just share my file. And before that, I would like to ask you what are the different parts of CPU that we did yesterday class. Like I told you input unit, output unit, storage unit, and fourth was processing unit. So what we studied in processing unit, what are the different parts of processor? Anybody remembers that? Okay. Francis and Zomana, I want to hear from you guys also. Zomana, you're only listening. What are the different parts of CPU which comes as processing unit? Okay. Norbert, please you go ahead. Then I'll show you that slide again. Yes, please
We have
come again.
register.
Yes, what are you saying?
The processor units. We have the registers, and
Can't hear you,
uh,
Norbert.
we have the registers.
I can't get you what you are saying.
I was like, we have the registers and I'll,
See, these parts I told you. CPU can be divided in two parts, ALU and control unit, CU. Now, can you explain? Anyone? Francis, Zomana. Now, can you explain? I have opened that slide for you. Different parts of CPU. Still, you can't explain. Okay, Norbert, please, you go ahead.
the parts of the CPU, we have the ALU and the control unit, of which the ALU is used for executing or performing of calculations in the computer, while the control unit is used to check out the information you have entered into the computer.
Okay, now can you repeat, Francis, what he said?
So he said we have the ALU, which is used in performing the arithmetical and logical operations on the
Yes,
computer.
yes.
Uh, while and then we have a control unit, uh, which is used in operations and controlling
Yes,
the
yes.
computer input and output
Right,
devices.
right, right. Romana, now can you repeat? Okay, so yes, Francis, mute yourself. So this says that CPU, which is the processing unit, that whatever instructions we give, that will be processed by the CPU. Now the point is that whatever instructions we give, whether we ask it to sort it, whether we ask it to multiply it, whether we ask it to divide it, okay, whatever instructions we are giving, all the instructions processor will perform only in two types of operations. Processor can perform only two types of operation. One is arithmetic operation, okay, using addition. It solves all the operations using addition. And second, it can perform logical operation. Okay, so these two types of operation, logical means and or operation. What is and or operation? If or if I say A and B, okay, so it's one condition and second condition. So if the result of all the conditions are true, then it gives the true result, and means this first point is come true, and second and third, whatever number of conditions I can give, 1 2 3, using and operator in between I can write. Okay, so if all the conditions give true, then and operation will give true result. Okay, logical operation means it will give only true or false, right? So and operation will give true only when all the conditions are true. Okay, and uh, what is the second? Or operation. Or operation, it will give true if any of the condition is true or all the conditions are true. Minimum one condition is true, even then it will give true result. Okay, so this you will do in detail later on. So here I am just telling you that CPU performs all the operation in two types of operations only, arithmetic and logical. That is why this is called ALU. So the part which actually does all the processing in CPU is the ALU. Okay, ALU does all the processing, right? And now what is the second part? that is CU, control unit. Okay, so control unit is which controls all the input and output operations. Okay, which controls all the input and output operations. So we just see whether all the supervision kind of role it will do, right? Whether all the input is coming, output is going, sequence of operations. Okay, so it will just kind of direction of, it will check all the overall functioning of all the units of computer. Okay, whether input is coming on time, whether output is going on time, it is connected properly. So all that supervision is done by the controller. And which part of CPU does the actual processing? ALU. And why this is called ALU? Because CPU can perform only two types of operations, arithmetic and logical operation. Whatever instruction will give, it will perform that instruction. Like if you, even if you give it, you tell the computer to subtract, it will do that subtraction using addition only. If you tell the computer to divide, internally it will divide using addition only. Okay, like that. So internally it can perform only arithmetic or logical operation, two types of operation, right? That is why this is called ALU. So this was just a revision of your fourth, that is processing unit. Okay, and okay, I just stopped sharing here. Right. Anything else you want to ask? Any other query you have? Okay, so I just open the next unit. As I said, we have to start with the software part. So here I have first explained that we just discussed what is hardware and what is software. So all the, you can say, electronic parts, mechanical parts, all the magnetic device, whichever devices are attached to the computer, whether it is, what is hard disk? Hard disk also come under your hardware, the printer, okay, your floppy disk, hard disk, everything comes under hardware. Okay, and your power supply, there is one fan also in the CPU to kill it, to keep it cool. Okay, for CD and DVDs also there is CD driver, right? Hard disk, motherboard, they, everything comes under hardware. What is graphic card? You know that there is one graphic card we use in the computer. What is graphic card? Yes.
I tried
Sorry, come again.
a graphic card.
What is graphic card? Why we use it?
A graphic is an computer expression card that generates a feedback of graphics output.
Your voice is not clear, Norbert. It's breaking.
I was like, a graphic card is a computer expansion card that generates a feedback of graphics.
No, I can't hear you clearly. I can't hear you. Zumana, are you just copying it from the internet and pasting it here in the chat box? Whether you know the answer, or just copying and pasting it from the Google. Yes, Zumana? What is graphic card, Zumana? Why we use it? Yes, Zumana, you haven't heard of graphic card? Do you play games? Video games? Francis, any idea?
Yeah, it's a circuit board in form of hardware that controls the output of a
And
display system and the
right,
computer.
right. And yes, Norbert, please want to say something?
Yes, a graphic card it's used to display to output graphics onto the monitor.
Yes, it is used to make the quality of your resolution better, of your graphics better. So generally, no, game players they use this graphic card, more advanced graphic cards. Okay, there are different types of graphic cards in the market. It depends how much better resolution you want, right? The latest card you can put in your motherboard, right? So what I was saying here that all this come under your hardware. Now, next term here it is mentioned is buses. Now, what is buses? Anyone knows what are buses? Anyone knows what are buses in a computer? Not buses on the road. Yes, Norbert, please tell me. So buses are the cables. Hard disk is connected with CPU. No, all these parts are connected to each other through some cables. So the cables that we use inside the system, inside your CPU, that is called buses. Okay, for traveling the instructions we have separate buses which are called instruction bus. For traveling the data within the CPU, within the computer, that those are called data buses. So buses means the cables that are used to connect different parts. Okay, so here I was just showing that everything, the CD drives, the buses, the hard disk, the fan, the graphic card, okay, power supply, SMPS is also there, which is used to for power supply. So this everything comes under hardware. Okay, so this we will continue from here tomorrow, right? Okay, so after 20 minutes we'll join for the lab session. Be ready with your systems, and there we'll continue with MS Word, right, all of you? And in theory tomorrow we'll start with. Okay, so with in theory tomorrow we'll start with from this topic onwards, hardware and software basically. Hardware we have already discussed. Yes, Abdullah, what is your doubt? You joined at the last time only, in the beginning and then at the last. You missed the entire lecture in between. Yes, Abdullah, tell me, what is your doubt? You just raise your hand and then you don't ask any query. Okay, after 20 minutes, yes, PDF, I am not able to copy and paste it here. I said I'll give you I'm writing my mail ID so you can send me mail. Okay, and I'll revert back. I'll send you this PDF. Just a second. I'm sending my mail ID. Yes, so I have sent my mail ID, so you guys can. Yes, I'll send you the mail on revert back on your mail. Okay. So we'll join after 15 minutes for the lab session. We be ready with your systems and MS Word. Okay. And Abdullah, you missed the whole lecture. So okay. Okay. See you after 15 minutes. Bye.